Hello everyone, this is Arham from Sri Venkateshwara College of Engineering, studying in the third semester in the Department of Computer Science Cybersecurity. Here with the subject Input and Output Operations in Digital Design and Computer Organization. Types of input and output operations. Data transfer involves moving data between various digital system components. For instance, data can be transferred between the CPU and memory or among different registers within the CPU. Memory access refers to the moving of data in the computer's memory. Example, it includes reading data or writing data to RAM or cache memory. Peripheral communication involves interaction between the computer and external devices or peripherals. Example includes sending data to a printer, receiving input from a keyboard, or transferring files to a USB drive. Reading and reminding you the basics over here. What is digital input? The function of it. It receives information from external devices. Example, a button press on the keyboard that translates a digital signal 1 or press 0 for unpressed that the computer interrupts as input. Applications of this digital input will be sensors, switches, keyboards, and joysticks, that is providing input to the computer. Digital output function sends information to control external devices. Example, a digital output signal from a computer tells an LED to turn to 1 or off, that is 0. Applications, it displays speakers and printers, motors, etc. Procedure for input and output operations. The procedure for input and output operation involves receiving data from external sources input and sending data to external destinations output. It includes steps like validation, processing, transfer. Proper handling ensures accurate data flow and system efficiency. Input and output operations in a computer. The gateway to the world of input and output operations are crucial for computer systems, allowing them to interact with the external world. Let's delve into the computer role in CPU operations. The two main input and output mapping techniques and the contrast approach to the interrupt-driven programmed input and output organization. That is, the data transfer that enables the CPU to exchange data with external devices like keyboards, printers, display, and storage units. The communication, they facilitate communication and protocols for networking and data transmission with computer. The device control I/O operations involve sending control signals to external devices to turn them on, off, adjust settings, or trigger the actions. Data initialization initializes the device by setting up its control registers and configuring its operating mode. Data transfer between the device and the computer using appropriate protocols and interfaces. Error handling handles any error that occurs during the input or output operation, such as data corruption or device failure. Binary representation. The language of zeros and ones. All digital information is encoded in binary code using only zeros and ones. Each bit of binary code represents a single state 0 or 1 group of bits, that is 8 bits is equal to 1 byte, from larger units to represent characters, numbers, or instructions. Digital input and output from the foundation of communication between computers and external devices enable us to interact with the computer and external devices that are essential for processing information, controlling the devices, and performing various tasks. Advancement of digital technology have led to faster and efficient input and output modes, influencing everything for communication and entertainment. Techniques for improving data input and output performance. Smoothing data flow, that is operations, can be bottlenecks in computer system. Thankfully, various techniques can help to optimize input and output performance for faster data transfer. That is, first one can be buffering. A temporary storage area in memory that holds data from being transferred to or from an input or output device. It reduces the number of requests by grouping small data transfer into larger and faster ones, minimizes the CPU wait time for slow input devices by buffering, while CPU performs the other task, improves responsiveness by having readily available data in memory. Caching stores frequently accessed data in faster access RAM closer to the processor. It benefits by retrieving data from the cache immediately instead of slower storage device. It improves the performance that rely on accessing repeatedly the same data and reduces wear and tear in storage devices by minimizing read and write operations. Thank you.